Good afternoon, ladies and gentlemen. That was a great presentation by Deepu. Fantastic, super exciting times as the physical world and AI intersect. I think this is just the start. Miller and Casey, thank you very much, first of all, for the opportunity to include Qualcomm in your event today. This is the second year that we are presenting in a row, and as Miller mentioned, we obviously have our roots in the mobile business. We've expanded into automotive. And this entire transition towards AI and the physical world intersecting create tremendous amount of opportunity. So I'll speak to you today mostly about how we are approaching this opportunity. And I think we are really at the very beginning of what I think will be a very interesting decade of change in front of us. The rate at which this change is happening is different across every industry, and at the same time, it is the same. Because there isn't really any industry that has gone through true physical transformation. Over the last 20 years, most industries were about capturing information from the edge, sending them to the cloud, but there was not as much of intelligence that was deployed at the edge. So most architectures really remained where intelligence was captured in the IT systems. The OT systems mostly remained focused on data capture. We were big beneficiaries as all of these networks got connected. We have been part and parcel of a lot of the connectivity layer. As you look at all of these various industries, they are very different. They all touch our lives on a day in and day out basis. And they have a tremendous amount of edge presence. If I think about this in the context of what moves the needle for all of our companies, all of our businesses, the amount of content, whether it is semiconductor content, whether it is software content, the amount of change that will happen over the next decade is going to be enormous. And there isn't really any recipe, there isn't really any playbook that is set up because this change, first of all, is very new. Secondly, these kinds of changes don't happen overnight. Things take time. These businesses are risk-averse businesses. These businesses need to be able to see change happen. I think, as was mentioned in the previous presentation, robotics, for example, very interesting space, but accuracy is going to be very important. It is the same across all of these various physical transformations. The approach that we take is a very broad-based approach. We touch many, many different technologies. We are an edge company at heart. We touch many different edge technologies, as you start to see from the bottom of the slide. The rate at which we think about change comes down to how do we actually influence what does it mean for a business to be able to evolve. Now, obviously, AI is one of many different facets of the change that is required. Ultimately, it comes down to scale. Ultimately, it comes down to cost of ownership, the ecosystem that you can create. And so the approach that we have taken, especially as we have looked at the industrial opportunity very broadly, is to really think about every type of connectivity, every type of compute, obviously intelligence included, but start to think about this in the context of enabling end products and being able to add intelligence in them. So I'll give you a sense as to the approach that we have taken as we start to go down that journey. One example, vision intelligence. And I think if we've started to use terms like vision language action models in a very common, rolls of the tongue. These were not things that were known even a couple of years ago. But the concept of a camera being the eyes of everything that we see around us is actually unimaginable. One approach that we have taken over the last 2 years is to really start to think about a chip-to-cloud solution from a camera perspective. We have recently acquired a company here in Taiwan that is part and parcel now of our IP camera solution. And the approach that we have taken is to really enable, at the silicon level, the intelligence to be able to look at what a camera is seeing, extract intelligence, annotate it, create the layers of outcome that you need to from the very end, from the very base of what is possible, and then track it all the way up. We are building video SaaS solutions that allow us to be able to wrap it up into a service. And we can look at this from any architecture. We can look at it from an edge AI box perspective, an on-prem appliance, and of course into the cloud. Why would we think of taking an approach like this? Because we believe that if you have to be able to make a change, you actually have to solve for the outcome. You can't just go provide the chip. You can't just go provide the solution. You actually have to be able to get to the end outcome. And we have started to see customers actually deploy this end-to-end. I'll give you some examples of what that looks like. The other acquisition that we made over the last 6 months was Arduino. We have not been a developer-first company in our history. We've mostly been a B2B company. We've focused on problem statements like mobility, more recently automotive. And the approach that we wanted to take, especially with the industrial business, was the innovation is going to come from the ecosystem. The innovation may not necessarily be captured within our customers. It may exist at the periphery of our customers. It may exist within entrepreneurs. And so the approach was to be able to put into the hands of developers very capable technology, very capable ecosystems, and then learn from that ecosystem what is possible. With Arduino, what we've been able to touch is a very wide variety of customers, very wide variety of developer customers that are developing directly on our platforms. And there isn't really any end to the types of applications that are being developed, because the types of models that we're enabling are various types of open source models that come from the ecosystem. And putting these boards in the hands of our developers allows us to be able to learn the rate at which this is moving. Now, what is very interesting about this, as partners like Advantech come in, as you start to develop an idea that is a project, you have to be able to figure out how to commercialize it. And so the approach that we have taken with ecosystems like Advantech are to be able to build a very seamless, and our partnership with Advantech is only about 3 years old. But to build a very seamless connection between how do you get developers to be able to develop on our platform, then convert that development into a system on module, into an SBC that ultimately results in an actual hardware. Now, we are looking at this very broadly. So we don't really differentiate between what type of end device you would like to manufacture, because we will really touch every single possible type of end device. And this is necessary because we want to be able to scale very quickly as this transformation happens. I think the other thing that we realize is that for this to be able to scale, there will not be a one-size-fits-all. For industries to be able to get to the right cost points, to be able to proliferate technology and change broadly, you have to be able to think about total cost of ownership. And this is why partners like Advantech are critical, because they understand the breadth, the fragmentation, the complexity of their business. We've done the same thing with a company we acquired last year by the name of Edge Impulse, which happened to be a partner company of Advantech for a number of years. Now, this is an MLOps platform that allows you to be able to train and tune models. And we have, over the last 6 months, come up with an approach that allows us to be able to do this on-prem. We have a number of our customers that don't wish to send their data to the cloud. They want to be able to keep the data within their premises. And we partnered with Advantech to take our AI 100 product, integrate the Edge Impulse platform on that product, and enable the ability to be able to actually train and fine-tune models online. This allows us to be able to build an end-to-end ecosystem within the premises of our partners where they're trying to bring AI into their ecosystem. This allows them to be able to go do that. And the approach that we take is very vertical focused. So, this is something that we've done in the history of the company, is to embed ourselves very deeply in what are the types of problems that our customers are seeing. Every customer has a very different type of problem statement depending upon the scale at which the approach is from. So for us to be able to take all the edge technologies that we have, find the intersection of connectivity, compute, AI, and then find use cases that customers are trying to solve for is the way that we start to go solve this. So for example, in this case, in the case of energy and utilities, back in our hometown in San Diego, we work with the local utility agency to be able to solve for problems around, for example, fires during very high wind pattern scenarios. We have high winds during the summer that usually creates challenges in terms of fires, and that requires you to be able to deploy tremendous amount of AI across a very large geography, which is Southern California. These are use cases that have very broad applicability. So we work with them, but we also work with their ecosystem to figure out how does this actually scale across a wide variety of other use cases. We've been working in the Middle East with ADNOC and Aramco to be able to look at how do you bring edge intelligence into their ecosystems, whether this is with drones or the ability to be able to detect risk in the case of a worker being, in some cases, not fully protected, or the ability to be able to monitor drilling operations remotely. I'll share with you what we are doing in the robotics space shortly in this area as well. As you start to look at the use cases, there are a lot of patterns. It really comes down to how do you drive autonomy? How do you drive the ability to be able to predict? How do you drive the ability to be able to detect something that is likely to happen? And these examples, as you start to apply AI, really come down to situational awareness. If you have a high degree of situational awareness in the environments that you're deploying in, you'll be able to come up with solutions, come up with models, come up with the right type of tools to be able to predict what will happen. And that is the approach that we are taking with our products as well as with a number of our partners. Retail is a space that is actually incredible. I like the retail vertical because it is probably the closest to what all of us expect to see change in. I equate retail, hospitality, healthcare. These are all environments that are likely to be changed by AI very quickly because there is certainly a human-facing element to these verticals. There is, of course, an instrumentation element. You will have, you'll have shelf labels, cameras, a wide variety of sensors that will normally be monitored from the cloud. These can now become intelligent at the edge. And of course, a lot of robotics, the ability to be able to add automation for skills that are well-defined. So retail is another area that we spend a lot of time on to be able to figure out how do we actually create blueprints that make sense for retailers to be able to go deploy AI in an aggressive way. As we switch to physical AI, now this is a super interesting space because if you think about the type of AI that has existed, even over the last 20 years, machine learning has been around for a long time. And it really comes down to how do you look at data and how do you drive some level of automation through that data. Now, as you start to look at industries and what type of automation they need, robots are one type of automation, obviously. But there is really the idea of being able to collect data, look at patterns. These patterns usually exist at the edge. And if you can have enough intelligence captured in these patterns and share that intelligence, you can push the intelligence into the operational plane. So we are spending a lot of time trying to figure out what's the best way to go do that. Now, the most complex example of this is to actually automate the job of a human being. So the approach that we take, we're an edge company. This is something that we've done for a long time. We believe one of the big challenges that the industry will run into as you have to scale this is these are going to have to be power efficient. They're going to have to last the whole day in terms of the battery life. They're going to have to communicate with their environment. They're going to have to be supported by a wide variety of embodiments. So they will not be a one-size-fits-all. And this means you have to be able to go at many different aspects. We break this down into System 2, which is the reasoning layer, System 1, which is the layer that is your faster reflex, and then System 0, which is the equivalent of your nervous system, which is your sensory layer. And all of these are going to be required for a robot to essentially be able to do what a human being can do. Now, obviously, there will be a timeline over which this happens. You can already imagine that tasks that require you to inspect can use a vision language model, and those are mostly in your perception layer with some amount of motion, some amount of locomotion in place. And then there are models that you can apply for physical dexterity that require more reflexes, the ability for you to be able to manipulate. But there is also a layer of communication. You have to be able to communicate with the environment around you. As robots start to scale, you will have to have a multi-robot scenario. You will have fleets of robots that will have to share information with each other. Many a times you will deploy robots in environments that don't have any connectivity to the larger world. These will be deployed in far-flung areas where you actually don't want humans to go. So the use cases will get more and more interesting, more and more complex. And for us, this is a systems type use case, things that we have done for a long time, things that are frankly very exciting for us to think very deeply about. And so this allows us to be able to think about every single type of end embodiment. AMRs have been around for a number of years. I think all of us have looked at this technology. As you start to think about moving up the stack towards what does it mean for a robot to be able to move, to be able to sense its surroundings, to be able to be dexterous in the way that it approaches a specific problem statement, to be able to do this in a power envelope that allows the entire system to be very efficient. These are problems that are, in the scheme of things, newer problems because there are many different issues. You have to be able to get the data. You have to be able to build models that are the right types of models. They all have to be able to run on the same embodiment. We expect that over the next 5 years, the industry will go through stages. There will be a lot of focus on inspection robots. A lot of that is starting to happen. You will start to see robots that will be used for transportation of goods, no different than what we've seen in self-driving cars. Robots will be able to carry equipment from place A to place B. Ultimately, you will start to see dexterity, first maybe with coarse skills, and then over time with fine skills. I agree with Deepu that these don't have to be general purpose. They can be specialized, and they will grow in intelligence over time. But they have to be system-level problems, and you have to be able to solve them to where they get to scale in terms of industry adoption. We've been working with Advantech, and Miller's team has been very gracious. The IQ9 product that we've been working on over the last couple of years has been refactored as a robotic platform, and this is something that allows us to be able to take these general-purpose SoCs and apply them into a wide variety of applications. This allows also for us to be able to take the same platform and provide it massive breadth. One of the things that we've done in our roadmap is to make sure that you have very broad applicability for the same platform. So these platforms are capable, of course, of running a lot of AI, a lot of sophisticated camera solutions. They're all built in with safety. They are designed for extreme environments, and that allows us to be able to move very quickly, especially as the market evolves. And we have introduced at Computex just today the IQ10 robotic reference design. This is the latest humanoid scale robotic reference design that we've introduced. And we believe this will actually be able to allow us to drive the next level of scaling as far as robotics applications go. This is a very interesting time because the distance between solving for a humanoid type application versus solving for something that is slightly before it, whether it's an ARM, whether it's an AMR, that distance really comes down to the amount of AI that you're trying to run concurrently. So with the IQ8, the IQ9, and the IQ10, we essentially have a family of products that allows you to be able to drive to that scale and focus on the ability to be able to scale this as quickly as possible. And finally, a big thank you to the Advantech team for being such a fantastic partner. I think we've really enjoyed the success that we've had with you, and I think the roadmap keeps evolving and expanding. So again, thank you very much, and thank you for your time.